Into what mycorrhizae is, but to kind of keep moving forward, they went through and they started Symbios, which is bulk blending and packaging, and then they went into, excuse me, in the mid-2000s they started the extreme gardening. Extreme gardening were known for the last 7 World Pumpkin Champions. The last one weighed 2,032 pounds. Tim Matheson was the gentleman from Napa, and he actually won in Morgan Hill. We actually seen it there at our facility. It's actually really interesting to see something that big grow to that size. No cracks in the shell. And so we know our products work in that regard. And we decided to take all those technologies and move them over into ag. We do have a landscape company called Green Diamond. We do offer the same type of products for them, but for what we're here today, we're looking at ag. So just a really quick reminder here, so everyone probably had their soil biology. I know Steve remembers these. So just looking at our soil food web here, contrary to what people do think, our agricultural land is getting depleted of all these good little organisms that you see here. Looking at your different levels, the one you have to really understand, to me and to a lot of people, the quarterback of this soil food web is the mycorrhizal fungi. They dictate what goes on with your nematodes, your bacteria, what exudates occur, how they're breaking down, metabolizing certain types of products. But with the more we go, and we have fumigation, changing the soil, even so we are introducing new fungi or pathogens by sharing equipment, people moving from one field to the other, not changing their boots, things like that, they really change the dynamics that we look at. So what we do is we're looking at the approach of, you go into a fumigated field where the actual bacterial level and fungi levels are gone. How can you reintroduce these beneficial bacteria and fungi back in to help farmers lower water usage, fertilizers, and everything to that degree? But there's something that's really important that people must understand. This is not the save-all wonder product that everyone probably thinks of mycorrhizae that it is. It's all in combination. They have to be used together. You can't just put your mycorrhizae and expect that you're going to get higher yields and you're going to save yourself from diseases. You have to use 2 or 3 biologicals and find that happy niche between all your guys that are working in the soil. It might be a little hard to see here. Up in the bottom, our bottom right-hand corner is what everyone wants to see, your visuals. This is actually a field, it looks like green field, but it's actually in Granada, Spain. We license a liquid mycorrhizae product. It's highly concentrated, can go through the drip, and I'll explain that in a little bit, but this is their control field. To the left is standard practice, growing practices there in Granada. To the right is using the liquid mycorrhizae. That same in vitro technology, we license and have the technology for it. And we started our new lab. Kelsey knows how much work we went through. So I think I'll start next week probably. A lot of work to undertake, but you can see the results here. In the middle are microgreens, and a little bit you can see a little radicchio. Bottom left is really hard to see, but actually that's a processing trial that we have. You'll see in a couple slides down the road. But it's the largest processing tomato producer in all of California, and they produce 40% of the United States processing tomatoes. We're doing a 2nd-year trial, so I wouldn't normally state their name, but we want to do it one more year, and then after that we're going to go into an agreement and release their name. Just one really quick here. This is actually what mycorrhizae does look like in the upper right-hand corner. It's hard to see, and there are actually handouts if you want to take one home with you of this presentation. But it's actually pretty much spores and hyphae and root fragments. That's the spore extraction in the upper right. The one in the middle is actually off our granular product that I done 2 weeks ago, and that's a root stain to check for colonization of roots. And in the upper left is actually, we use an independent mycologist to confirm our numbers and confirm our growth, and that's actually a stain he had done in his lab. Okay, so essentially what occurs is mycorrhizae. We use actually a vesicular or muscular mycorrhizae, which people probably don't know what that is, but essentially what it is, it's a mycorrhizae, and there's thousands of them that we have native to our soils. The one we concentrate on are 2. One is called Aglamus intraradices, which we utilize in our granular product, and we're now moving to a European strain that we're getting registered now. It's called Rhizophagus regularis, but they're both essentially the same. So what actually occurs is that mycorrhizae have a symbiotic relationship with the roots. So what happens is once the actual mycorrhizae colonizes the roots, they pass each other nutrients and sugars to help each other out essentially. So what happens is that the mycorrhizae goes in and it actually lodges itself within the root fragment, and then it passes nutrients, water, your phosphorus, your nitrogen, your potassium, your microelements, which the plant normally would have have a lot of difficulty trying to utilize, either because it's tied up in different formats chemically wise. Let's say, of course, in our soils here, we go 10 feet and you can put a whole bucket of water and not even 1 milliliter will drain, and then you can go 20 feet and you can put the bucket in, it might drain half the bucket. What essentially also occurs though is that by the passing of the minerals into the water to the plant gets back sugars. And it's actually in the form of a glycoprotein, and the fungi takes that and it sloughs off and it starts binding your soil particles. So you end up starting getting pore space for air, for water, for the roots to move down and start mining deeper for other types of minerals and nutrients. Now what also occurs there is that the roots help the plant get bigger. The masses on some of these plants that we've seen, I mean, they're just absolutely ridiculous. Some of your small fine hair roots and some of these clay pans or some of these really hard soils are just really tremendous. And when we get to the next slide, I think I've actually put one in there for it. Now we're moving to the bacteria. So in regards to that, we also offer a nitrogen fixing bacteria. Now this is an azospirillum variety. You can kind of see here, these are a little rare, it's actually nicer on the slide, but for ourselves here, what would work basically would be your broccolis, your spinach, your cabbage, and your kales. Now, not all plants have a relationship with mycorrhizae. There's 94%, I believe, of the world plants do, and some that the ones that do not, it's still up to debate whether or not those plants are technologically or have assimilated, so they don't need that help. But for those plants, we do use the azospirillum. What it does is when nitrogen levels are low, it pulls atmospheric nitrogen and fixates them through the leaves, and it helps the plant actually perk up, per se. We do use it both in combination, and we do offer this in a liquid format also. 16 ounces for both products goes into an injection well, and that actually treats 1 full acre. So with the azospirillum, what occurs there actually is that increases the amount of IAA, which is essential for root growth, and all the other secondary compounds that are actually affiliated with your root growth are actually increased. Now what happens with the two, the azospirillum increases the root size, and then that allows more surface area for the mycorrhizae to go in and colonize that area, and then the mycorrhizae helps for the plants to get bigger. Now the two in combination, we were talking about water, and we look at disease. I know some of the strawberry growers, we're looking at macrophyllina. You look at some of the other diseases that are prevalent along Santa Maria, Ventura, Oxnard. The key word is not, you're never going to eradicate disease. What I like to say is that if you have a healthy immune system, like humans, like we do, you'll be able to resist disease. So if the plant's root mass are actually of tremendous size and healthiness, they will be able to withstand disease. They will never eradicate disease. They'll just be able to get through your stands so you don't lose your whole yield. Speaking with the farmer, we actually had a trial last year. One of his fields was hit with macrophyllina, but he was able to withstand that loss longer than most people within his road there, and he was actually only able to yield 32%. But everyone within a quarter mile of his farm or his ranch only yielded 6%. Now that's significant when you look at, I'm just going to lose the whole field as opposed to even 15 to 20 for next year's growth. Okay, so going back to that processing tomato trial, they do over 125,000 acres in California. So we have last year we had done, before Kelsey came on, I had 4 different trials with this company. We did blocks of 16 acres, 4 acres, we had random blocks. But for this trial, the one that I'm focusing here, we actually sprayed at the nursery. once they were hardened off and they were sitting on their racks. Once they were given their last dose of their fertilizer, their high dose of calcium, they were in the field for 2 weeks before they get sent out to be planted. So we sprayed both products. Now, if you can see here, for this company, they advertise lycopene. Now, yield for them is number one. They want to be able to yield the most, lower their input value, and they would be able to get what they wanted. We were able to fractionally increase their yield. However, the field was harvested 2.5 weeks early because the road that actually where it went to was so dangerous to get those big harvesters in. Once they're in, and they're not going to go back out. They go in, they finish the area, and it was over 582 acres. So they're in, they're not coming out. But the numbers that are significant are here. Actually, we utilize the National Food Labs, and at this, the control is C, single treatment and single treatment two blocks within each other. They're both 6 acres. They were both sprayed at the same time. And the third one down here, the double treatment, was sprayed at the same time as these other single treatments, but there was an injection later in the season. And you can see there's almost 3 times the amount of parts per million for the lycopene numbers. And for them, that's tremendous. Not only are they going to increase their yield, lower their water, lower their fertilizer over time, which we have to track, but they would be able to utilize this as a secondary marketing value. And the only reason why these secondary compounds are utilized or being able to be processed is because the mycorrhizal the azospirillum helps the plant utilize those microelements that it normally would not be able to use. And those would also be your taste,